Hello everyone, my name is Umesh Kumar and here are my teammates Arush and Divyan. We are Group 11 and our project title is Membrane Material for Desalination of Seawater. So coming to the problem statement. So in most of the Middle East countries, there is shortage of water because they don't have any fixed source like rivers or any groundwater. So they only depends on sea. Now sea also contains some salts in their water. So first they need to remove this salt by a desalination process in which they use several techniques. So for this desalination process, we have to design a membrane material and select on the basis of its efficiency. Now, coming to the methods of desalination, there are three types of desalination by which desalination can be done. First is thermal desalination, in which we provide external heat to boil the water, and the residue left behind is the salts, and we can remove these salt particles. Next is the freezing desalination. In this, we cool the solution, due to which the salt crystals will form the ice type of structure and they can be separated out easily by using a filter. Then coming to the capacitive deionization, in this we use electrodes and by a process of electrolysis, the salts will decompose on this, will like decompose on deposit on this electrode and the clear water can be passed. Now, because we are using the membrane material and researching on it, so we found that reverse osmosis with the continuous operation is the best choice for desalination of seawater. Now, what are the benefits of reverse osmosis? First is it uses the less energy as compared to this thermal and freezing. Because it uses less energy, it is highly cost effective and it can be easily scaled and flexible. And one of the main reason is that it efficiently removes the salts and impurities from the water. That's why it provides high purity of water. Next, coming to the environmental impact. So as compared to the above three methods, the RO method is provides a lower environmental impact.
So, as we are targeting industrial applications of desalination, we are targeting the Arabian Sea seawater as a base, and we have some properties which we used in order to calculate the membrane properties. First is salinity, where we observe that Arabian Sea has 35 parts per thousand of salt. Second, its pH is 8.2, which is used to calculate the corrosiveness. Third, majority of the ions present is chloride, sodium, and the secondary ions are sulfate, magnesium, calcium, and potassium. As you can see in the left table, the maximum radius of the membrane which we need to have is of 0.27 nanometers. So we need to design that membrane so that these particles can be removed efficiently. The second table gives a brief gives a brief idea of the concentrations of various ions present in seawater. Typical seawater has this concentration, but we are targeting the third column itself.
So now I'll talk about the different factors affecting membrane selection. So the first point is, as Divi mentioned, there are different types of salt ions like Na plus, Mg plus, Cl minus, and SO42 minus. So the relative concentration of that will vary, and that will actually affect the membrane material we select. Then, considering that we are using industrial application of seawater desalination, so we'll have to consider the 3 to 5 years timeline of every membrane. That's the durability. Mechanical strength and flexibility is also an important factor in determining its overall life cycle and its strength. So Young's modulus is of the order of 1 to 3 gigapascals. Capital and maintenance cost, that will come under a techno-economic analysis where we'll find out how cost effective the membrane is. Then the number of membrane layers, and generally there are three types of layers: polyamide, polysulfone, and polyester layers for support. The last 2 points are transfer parameters like diffusion coefficient, heat transfer coefficient, viscosity, etc., and the porosity of the membrane pores. That will also affect the transfer properties. So now we looked through rigorous literature review and found three important materials which are used in current membrane RO technologies: aquaporants, carbon nanotubes, and nanoparticles using polymer membranes. So aquaporants are actually bio-based solutions which have unique transfer properties, and they're not only highly permeable to water, but they're also providing good selectivity. Carbon nanotubes, in this case, double and single walled nanotubes, both have showed flow velocities which are far exceeding theoretical prediction. That means they're very efficient in uh, transferring salt and removing it from water. 0.98 nanometer TNTs are very useful in this case, and they provide a fourfold improvement in flux over the thin composite RO membranes. Nanoparticles, this we won't be covering majorly, but yeah, that it uses titanium oxide with photocatalytic properties. So now we'll go into the main RO material, which is single walled carbon nanotubes. They are synthesized using the process of chemical vapor deposition, which uses catalysis. The membrane structure is in our project will be single walled carbon nanotube with a core diameter of 0.2 nanometers. This is designed based on the hydrated ion sizes which we'll be dealing with. Then they will be embedded in a polymer matrix of either polysulfone or polyamide. And occasionally we might add functional groups like carboxyl or hydroxyl to enhance their affinity for water molecules and improve efficiency.
So this is our general calculations which we did in order to calculate the number of membranes used. So we assume that the typical flux would be around 10,000 to 1 lakh liters per meter square R per unit bar due to the frictionless flow of water molecules through the nanotubes. So, and we've estimated the required daily desalination of water, which will be around 7.6 into 10 raised to power 8 liters per day. Assuming the membrane surface area is about 10 meters square and the operating pressure is 28 bars, we calculated the total membrane area required as 112.85 meters square and divided it by the single surface area, we'll get around 12 membranes which must be used in order to carry out these functions. Here are some references which we did, which can be reviewed later on. So couple of things which we need to keep in mind are the maintenance requirements for this membrane. First, in order to clean these membranes, we need to use about 0.2% hydrogen peroxide, which is a more efficient in order to remove the brine particles from the deposited on the membrane. Second is to remove filters, which need to be replaced about every week. Third is to replace membranes. As Arush mentioned, the durability is about 1 to 5 years. We will have to replace the membranes accordingly. And here are the other factors which might be required.
Okay, so next thing which we deal with is environmental impact. That this process of desalination, that how it will impact on the environment. First is the energy use. Because desalination is the highly energy intensive process, it uses the heating process. So for heating, the fuel will come from the burning of fossil fuels, and it will release some greenhouse gases which will go in our atmosphere and lead to the greenhouse effect. Second one comes to the brine wastage. Like the byproduct of this desalination is brine, which can be directly put into the river or sea and decrease the quality of water. And it is also harmful for the marine life. Also, due to the pipeline leakage, which connect the sea to the industry, they may contaminate with the groundwater and like decrease the water quality. Then coming to the noise pollution and the community land used in the desalination process. So thank you. This is our presentation for our topic. And yeah.